Hello friends, and today we are going to study a new numerical which is based on a trigonometric Fourier series. So first of all, we'll see which type of question will be asked in exam. So let's see the question first. The question is, determine trigonometric Fourier series or trigonometric form of Fourier series of given waveform. Now, mostly they'll give you a waveform which is maybe a continuous, or we can say maybe a periodic or may not be periodic. Right now this graph is periodic, and if this graph is periodic, so we can calculate the Fourier series, or we can say that Fourier series type, that is trigonometric or exponential. So first of all, here it is asked, calculate the trigonometric Fourier series. Now look at here, in this graph I can say that this graph gives us even symmetry, and if we have even symmetry, then we will calculate only a naught and an values, because in even symmetry my bn value is always 0. So first of all, we will write the equation of x of t, then we will discuss what will be the solution. So first of all, we will write the equation of x of t, and then we'll move on to a naught and an. As I said, my x of t is having even symmetry, which means we will have only an and a naught value, and my bn value is 0. So these are the two formulas of a naught and an for even symmetry, and we know that for even symmetry or in even symmetry bn value is 0. But first of all, what is the value of x of t? What is the total time period of this x of t function? So first of all, we'll see the question first, so that you will get the idea what are the x of t, or what are the different amplitudes we have in x of t, and what is the actual time period given in x of t. Now look at here, in this graph we have a total time period, that is 0 to t. This one cycle is completed, so I can say that my total time period of this x of t is only t. So look at here, in basically in question, so basically in a naught and an values we have written 4 upon t naught, and the integration limit, higher limit of integration is t naught by 2. If I substitute t naught equals to t, so what you will get? We will integrate our function only from 0 to t by 2, and 0 to t by 2 means what? We will solve only this slope. This is the positive ramp, so we can calculate the slope value, and we will substitute that value in my x of t equation. So first of all, we will write the x of t equation, and then we will go to solve a naught and an values. This is the location of y0 and x of 0, and this is the location of y1 and x1. So according to my slope formula, I can say that, let's say my slope is m, and we can write the equation like y2 minus y1 upon x2 minus x1. Now my y2 value means in between 0 to t by 2. This is the value of y2, and this one is the value of y1. Similarly, this is the value of x1, and this one is the value of x2. So we will substitute all this value in my formula. So my y1 and x1 value is 0. But my y2 value is a, and my x2 value is t by 2. So I can say that my slope value is a upon t by 2. So my total slope becomes 2a by t. So I'm going to substitute this slope value which is available in between 0 to t by 2. So I can say that my x of t is having a value a by t into t, but in between 0 to t by 2. So first of all, we'll substitute this x of t value in my a naught formula, and then later on we'll substitute in an formula. Now, my t naught value is t. So we'll substitute both the value first, and I'm going to substitute x of t value, which is available in between 0 to t by 2. In between 0 t by 2, we have the value, or we have calculated the value, which is 2a by t into a small t with respect to dt we are going to integrate. Now, this whole integration is depends upon the value of t. So I can say that 2a by t is constant. So I will take this value outside. And what else is remaining inside this bracket? We have only t. And integration of t to the power n is always t to the power n plus 1 upon n plus 1. That is, here we have the order or value 1. So we can write the integration, that is t square by 2. Now, I can say that this 2 and this 2 get cancelled, and t into t is t square. So we'll write 4a by t square, and we will substitute this upper limit and lower limit in this formula. This t into t is t square. So we can write 4a by t square, and then we'll substitute t by 2 and 0 value in this t square. So first of all, we'll substitute upper limit. So this will be t by 2 the whole square, and next one is 0. That is 0 square is always means as a 0. Now, t square, or you can say t by 2 the whole square, is always t square by 4, and t square by 4 minus 0 is always t square by 4. Now look at here, this 4 gets cancelled, as well as this t square also gets cancelled. So what you will get? Only a. So my a naught value is a only. Now similarly, we will calculate my an value. So next part is my an. So first of all, we'll write the formula of n. Now, we will substitute my x of t value in this formula. My t naught value is t, so we'll write 4 by t only, and my integration limit is 0 to t by 2. My x of t value was 2a by t into a small t, and this is multiplied with cos of n omega 0 t. Now look at here. This 2a by t is a constant because we are going to integrate only a small t functions, or the functions which is having a small t. So I'll take 2a by t constant. So I have taken 2a by t outside this integration. And now what we have? T into cos of n omega 0 t. Basically, we have studied one formula, that is integration of u into v. In this case, we will use a Lie form. In Lie form, this a is algebraic and t stands for trigonometric. So this t is nothing but my u, and this trigonometric function is nothing but my v. So according to Lie form, or we can say according to integration of u into v, we can write this formula u integration of v minus integration of derivative of u integration of v. Now we will substitute all my u and v formula in this part. So 4 2s are 8, and t into t is t square. So we'll write. And now t into integration of v, that is integration of cos of n omega naught t, is always sine n omega naught t upon n omega naught. Now the next part, If we differentiate this t with respect to t, then dt gets cancelled, so we'll have only 1 over there. And the integration of v, that is integration of cos of n omega naught t, which is already solved. And our integration limit I have placed over here. Now again we have to integrate the sine n omega naught t. Now what is the integration of sine at? Now the integration of sine n omega naught. Now we know that integration of sine at is always minus cos at by a. So here my a value is n omega naught. We already have n omega naught in denominator. So after solving this integration, we will write, or we will have n square upon omega naught the whole square, and numerator we will write only cos of n omega naught. So I have substituted all the values of integration of sine n omega naught, which is minus cos n omega naught upon n omega naught. So n omega naught into n omega naught is n square into omega naught square, and the integration is minus cos, so minus minus sign changes to plus. Now we will substitute all the upper limit and lower limit in these two parts. So first of all, we will substitute upper limit and then lower limit in this first part, and then we will substitute upper limit and lower limit in second part. So all these t is first of all replaced by t by 2 and then later on 0. Now if I substitute t is equals to 0, so whole term replaced by 0. This is our first part. Now similarly we'll substitute t by 2 and 0 in this next part. Now if this t is replaced by 0, then cos 0 is always 1. So I can say that we will have only 1 upon n square minus omega naught square. Then we will have 1 upon n square into omega naught square. Now the next part is we will substitute our omega naught value. Basically my t naught value is t. So therefore what is my omega naught? It is nothing but 2 pi by t naught, and my t naught value is t. So we will substitute, or we will replace all the omega naught by 2 pi by t. So this all omega naught is replaced by 2 pi by t only. Now I have replaced my omega naught values by t by 2. Here also we have replaced by t by 2. Now 2 gets cancelled, as well as tt will also get cancelled. So what is remaining? Sine n pi in this first part. Now here also tt will get cancelled, and my 2 also will get cancelled. So we will have only cos of n pi in second bracket. Now look at here, sine n pi is always 0, but cos of n pi is always minus 1 raised to n. So if I substitute sin n pi equals to 0, so whole first term will get vanished. And if I replace cos n pi by minus 1 raised to n, so we'll have only second part, and in numerator we'll write minus 1 raised to n minus 1 upon n square omega naught square. Now, this is the value of an, but still this an value depends on the value of n. Now, if I substitute n equals to even, and if I substitute n equals to odd, my an value will change. So let's see what different values you will get after substituting n as a even values or n as a odd values. First of all, I have replaced my omega naught by 2 pi by t. Now, if we take the square of this 2 pi, so we will have a 4 pi, and in denominator we will get the t square. So I can write this equation like this. Now, only single t will get cancelled, so we will have 1 t in numerator, and if I divide this 8 by 4, so you will get 2. So my answer will be 280 or 2ta n square pi square, and in bracket we will write. Now here we'll substitute the value of n. So first of all, if my n is even, then minus 1 raised to 0 is always 1 if I keep n as an even. You can take 2 also, you can take 4 also, you can take 6 also, you can take any even values. Minus 1 raised to even is always 1, and 1 minus 1 becomes 0, and 0 into anything is always 0. So my an value is always 0, but for n is even. But if n is odd, then minus 1 raised to 1 is minus 1. So we will have minus 1, minus 1, minus 2, and minus 2 is multiplied with this 2. So you will get minus 480 n square pi square. So you will get the answer for all n values or odd values of n. But for even values you will get answer 0. If I take n equals to 3, then also you will get minus 1 in minus 1. So you will get minus 2, and minus 2 into 2 is minus 4. So you will have a minus 4 t a upon this will be a 3 square, that is 9 pi square. So you will get the answer. Here I have substituted my n value as a 1. So this n square will be replaced by pi square only. So if I take n equals to 3, so you will get 9 square. Now if you take n equals to 3, so you will get n square, that is 9. If I take n equals to 5, then you will get 25 in the denominator. So I can say that if I substitute all n value as a odd, you will get the finite value which is non-zero. So I'm going to use a trigonometric form of exponential series, and I'm so going to substitute my an 0 value and an values in that. But listen, my an value is only available for odd values of n, and for even values the value is 0. Now here my bn value is 0, so I have substituted my an values. But look at here, what we have, minus 1 raised to n minus 1, and this value is solved only for n equals to odd. And if I substitute n as a 1 or as a 3, or if I replace this n by 1, 3, 5, whatever you want to say, you will get the answer minus 2. So I'll take this minus 2 over here. So this will be replaced by this a by 2 remains same, and my an value changes to minus 480 upon n square by pi square. Now here I have not substituted the value of n, because if I substitute n equals to 1, then this will be only a 1. But if I substitute n equals to 3, then this will be a 9. If I substitute n equals to 5 or 7, then this will be 25 or 49. So you will get the answer for all n values, but if it is odd, numerator will not be changed. That's why I have written n square in the denominator. I have not substituted the n values, because this value changes according to the n equals to odd values. So this is all about this question. We will solve a next question in next video. So thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.